I'm here with Trion. We're here at Cal Poly. The IME department stands for
Industrial and Manufacturing Engineering.
And today's a big day.
Out there.
Yeah, today's a big day because you've got some Kent mills, and you told me before these are half manual, half CNC, right? Because you got the digital readouts.
Correct.
And the students have been using those for...
They've been performing conversational programming on it in order to learn the fundamentals of milling. Because as engineers, they're not going to be machinists. They're going to learn how to design and design the next tooling or the next product out there in order to manufacture the next design. So what we're going to be doing is we're going to be teaching them more automated manufacturing processes with our Haas CNC mills.
Which we're getting today, so we're waiting for the rigger to pull up right now. So you've been planning this for a while.
Correct. So, since I came to Cal Poly 4 years ago, my plan was to get rid of these boat anchors and bring us up to the next level in manufacturing by installing 6 Haas mini mills.
How many students do you have here at Cal Poly? They're going to be touching these CNCs.
I run 700 freshmen through this lab every year. That's 3 quarters. And what we have is we have lab sections of 24 students. So I've got 24 engineering students on here at a time where I'll have 12 students on the mills, 12 students on the LeBlanc lathe. We'll be learning the fundamentals of machining through lab experiences, practical hands-on lab
Making actually some of those products that you showed me from your office.
Correct. So they're going to be learning how to turn, face. They're going to be learning how to touch off tooling and drive tool paths for like face mills, end mills, drills, and so forth.
What do you see from your students when they come through your program?
So what I see them coming through my program, they're all going to be industry-ready graduates once they receive their degree. So this lab is dedicated to freshman manufacturing. So as freshmen, they come in here and they learn what a mill is, learn how to create a chip, learn how to calculate feeds and speeds, and so forth. And they take this knowledge and they're able to progress into higher level manufacturing throughout their career here at Cal Poly. And hopefully upon graduation, they'll be able to hit the ground running in industry and make effective changes very quickly in their workplace for their employer. This is Wyatt Hall, one of our manufacturing engineering students. He was my lab tech for 3 years. An incredible CNC machinist.
So what's next for you?
I am going up to Seattle next week for interviews for jobs.
Like in manufacturing,
In
making things,
manufacturing,
design?
Yeah, so it's a small company, 16 people, so I'd be running manufacturing for them.
Going in industry,
Hitting the ground running.
hitting the ground running.
That's what that industry really loves about our graduates is they can do stuff when they leave here.
Right.
With all the math, the statics, the dynamics, the strength of materials. But on top of that, they actually learn by getting dirty in the labs, producing parts, learning what a tolerance is, learning how to inspect parts, and learning how to program. So this lab is dedicated to teaching engineers manufacturing. So we're not a project lab. We teach machining in this lab for all freshmen. So this is a freshman manufacturing lab. We have an advanced lab next door where we have 4- and 5-axis CNC machines.
Yeah.
Because once they learn how to simply walk in here, they can then start programming the next generation to machines.
Freshmen in here, they come in,
Correct.
they get introduced to the manual mills and lathes.
Correct.
And now CNC.
Correct.
And then they move on to another department next door.
Yes, so it's still our department.
Still your
another
department.
lab next door. It's the Gene Haas Advanced Manufacturing Lab next door. Thanks to the Gene Haas Foundation, we were able to make significant improvements in that lab. Phase 2 of our plan here, in order to upgrade our freshman manufacturing lab, would be to get rid of these 1954 LeBlanc boat anchors. If you look, back to part of the Cal Poly tradition, we've had these machines since the 1960s, 1950s, and it's time to upgrade. One of our students, Nathan Harry, machined a 5-axis class ring. He was in the mechanical engineering department. He was also on the Baja team and a graduate of Cal Poly SLO 2018. Mastercam Haas 5-axis. These are our freshman machining project. These are our air motor. It's a Cal Poly legacy. We've been producing the air motor for 30 years. This is actually the 30th anniversary. So to send out the Kent mills in style, we did a billet production. Part of our tooling design class, our manufacturing engineers designed tooling for our plastic injection molding machine, where they design the molds in order to produce screwdrivers. Scott, this is what we got going on. We had 6 mills along the wall right here. Now we're replacing them. I moved a LeBlanc lathe out over here. We're gonna have 6 Haas mills in an L configuration along that back wall. We got plenty of visibility in the lab, so we can have an instructor on the LeBlanc lathe here and still see all the students working on the lathe. and then also see the students working on the mill. So this was funded thanks to taxpayer money and a little surplus we had left over, and it's going to make our lab a lot safer to work in.
When do classes start up again?
Classes start third week in September. Let's get them installed. Time to hook them all up, electrical, air, finish the lab manual, and the students will be here in 2 months to start classes and making chips.